Pre-flight 101, the course that will keep your wings. 4. Pre-flight checks and flight dispatch guidelines. 4.4. Filling a weight and balance document. As we mentioned before in this section, it is mandatory to carry a weight and balance sheet for every flight in order to comply with regulations. We're going to learn now how to fill up this document. As you will see just in a moment, it only requires knowing how to add, subtract, multiply, and divide, and with a bit of practice, you'll be able to fill one up in a matter of minutes. This is a standard weight and balance document, okay? As you can see, it's composed from two sections. We have the calculation section, okay, and we have the graphic section. We're gonna see now how to use both of them. But the thing I want to start with is a really easy example. A plane is basically like those games that kids play in the park where there is kind of a balance. If both kids go in the balance at the same time, the kid that weighs the most is going to go down, and the kid that weighs less is going to go up. With airplanes, we don't want the airplane to be tipping on the tail. We don't want the airplane to be falling forward. We want the airplane to be kept balanced, okay? So this is where the balance comes from. If you think about physics in secondary school or even in primary school, you might remember a formula that said something like moment equals weight times arm, which means a light kid, a really lightweight kid, might be able to lift a bigger kid if the bigger kid is closer to the datum or to the origin than the other kid. So the farther we apply the force, or the weight in this case, the more moment we are going to create, okay? So in aircraft, we want to equalize all the moments, okay, in order to keep our center of gravity, you see, center of gravity inside this box right here that we're gonna call an envelope, okay? If our center of gravity is anywhere inside the envelope, that means we are able to fly safely. Now, we are also talking about weights, right? So these are the weights. If we keep our weight anywhere inside this graph, we are going to be able to fly safely. Now you know that there is another formula that says index equals moment times a constant. So in this case, our constant is going to be 1000. Why? Okay, imagine you multiply the weight of something, let's say 200. Okay, so are you with me? Weight 200 times arm 200 again. You're gonna get a really big number. If we divide that moment, that big number, times 1000, in this case, we're gonna get a smaller number. So an index is just the same thing as a moment divided by a constant, so the numbers are smaller. Nothing is changing, only the number that we are going to be setting. All right, so let's slowly begin with the weight and balance calculations. The first part is the basic empty weight. This weight is given by the manufacturer, is basically how much the airplane weighs when nothing is in it. Okay, no fuel, no people, no nothing. If you go to a specialized weight and balance book, you are gonna find many different weights But that is not the matter of this course. We're just gonna just think that the basic empty weight is basically the empty aircraft. Okay. Here we have the maximum zero fuel weight, maximum ramp weight, maximum takeoff weight, maximum landing weight. Those boxes are there just to be filled and to remind you what your maximums are. Okay, so if your actual is bigger than your maximum, you cannot depart. Okay, I think that's pretty easy to understand. Anyway, that's just the model of the Cessna, and that's the center of gravity, as I said before. We will see how to use this graph after. For now, our basic empty weight is going to be 1,716.5 pounds. Okay, the initial arm is going to be 40.91. So if we calculate our moment, we multiply 16.5 times 40, we are going to get exactly this number that we have here. Okay, we're going to get 70. Wait a moment. If I multiply 1,700 times 40, I don't get 70. I get 70,000. What's going on here? Well, what is going on is that here we actually have an index. Okay, so do it for me in the calculator, please. Just get in the documentation section this load sheet, or do this load sheet in a piece of paper, but follow me in the explanation. Okay, so multiply 1,716 times 0.5 times 40.91. You're gonna get something like 70,219 or something like that. If you divide that number by our constant, that is 1,000, you're gonna get 70.22. Okay, let's keep going. Our front passenger is going to weigh 340 pounds, because it's me, the pilot, and the person sitting next to me in this case is going to be the instructor. The arm, we actually get it here. Okay, the manufacturer gives us the arm. Okay, if you're not sure about the arm of these stations, just go to the weight and balance section in the POH and look at the diagrams. In that diagram, they're going to tell you what the arm is for the different sections. If I multiply 340 times 37 and I divide it by 1,000, I'm going to get, with that formula, a number of 12.58. Okay, so I multiply weight times arm and I get a moment. In this case, an index, just to make the number smaller, is the only thing. No rear passengers, which means no rear moment. Okay, 0 times 73 is obviously 0. Okay, in the baggage area 1, I'm gonna be carrying my sandwich and that's gonna be 15 pounds. Yes, it's a big sandwich. 15 times 95, it's gonna give us 1.43. Again, this is an index. Okay, this probably 15 times 95 is equal to 1,420 something, 25 I think it was, or something like that. So we're just gonna round it up to 1.43 because we divided by 1,000. The next thing we're gonna do is the baggage area 2. 0 kilograms in the baggage area 2 times 123, 0, and that is easy. Okay, now we go to one of the special lines in our mass and balance calculations. These ones are special lines. Okay, this is a special line, this is another special line, this is another special line, and the last one is also another special line. Okay, we're gonna see that the working principle is a bit different. In the normal lines, we multiply the weight times the arm to get the moment. Let's see what happens in these others. So we add all the weights, this plus this, so the empty aircraft plus the front passenger plus the rear passengers plus the baggage area 1 plus the baggage area 2, it all adds up to the actual zero fuel weight. So everything that is inside of the aircraft with no fuel. Now let's do the same with the moments. 70.22 plus 12.58 times plus 0 plus 143 plus 0 is going to be equal to 84.23. Now if we apply the formula on the opposite side, if I have a moment here and I have a weight here, I can get the arm, and that's what I want. I want to get this arm. So I'm going to divide this by this, okay, and multiply it by 1000. So 84.23 times 1000 divided by 2071.5 equals, using that formula, 40.66. Okay, that's how we do these special lines. Next thing we're going to add up is the fuel on board, how much fuel we're going to put on that aircraft. And this is a normal column. This is not a special one anymore. Okay, the special ones are only these ones. Okay, these are add up lines, these are normal lines. So the fuel on board is going to be 180 pounds multiplied by an arm of 48 and divided by 1000, we're going to get 8.64. Again, we have another special line. Okay, so we have to add, right? So we had the aircraft empty, okay, no fuel. Now I'm gonna put the fuel on board. So if the empty aircraft was 2071.5 pounds and we are putting 180 pounds of fuel in it, our actual ramp weight is going to be 2251.5 pounds. Now we're going to do the same with the momentums, and we're going to get a 92.87. This is a special line. We're going to do exactly the same as we did to get 40.66. You can go back to that step if you need to. 92.87 times 1000 divided by 2251.5 equals 41.24. Good. Let's continue with the next one. Taxi and run-up fuel. How much fuel we're going to burn for the engine run-up and the taxi to the threshold. Okay, in this case I've calculated that we're going to burn about 7 pounds of fuel to do all that. This is a normal line, so we just multiply -7 times 48. What do we get? -0.34 is going to be our index. Okay, we get here another special line. So we had the actual ramp weight with all the fuel, all the people, my sandwich in the back. We have everything there. Now I'm going to subtract, and be careful here. We want to subtract this, not add it. Okay, you are not gaining fuel, you are burning fuel, you are subtracting fuel, and the same happens with the moment. Okay, so we're going to subtract those 7 pounds of fuel from the initial ramp weight. We're going to get 2244.5. With the moments or with the indexes, whatever you need, we're going to do the exact same. 92.87 minus 0.34. We're going to get 92.53. Using the same formula like we did before, okay, changing the formula and doing the same thing as in the previous step, 92.53 times 1000 divided by 2244.5 is going to equal 41.22. Good. Now we're going to repeat the same thing with the trip fuel. How much fuel am I going to burn in my trip during the flight? Okay, so I calculated that I'm going to burn about 120 pounds of fuel. 120 pounds of fuel multiplied by 48 is going to give me minus 5.76 index. Okay, again, another special line. I'm going to add up. I had the takeoff weight. Now I'm going to subtract. Remember, we also subtract here. We are not adding fuel. We are burning fuel. Okay, 2,244.5 minus 120 is going to equal 2,124.5. Okay, and 92.53 minus 5.76 is going to equal 86.77. Okay, again, doing the same thing as we did before, we are going to get that momentum of 40.84. Now, I want you to take a look at certain numbers. Okay, I'm going to mark them for you here in this green, nice, bright color. So I want you to take a look at the actual takeoff weight. Okay, and I want you to take a look at the actual takeoff center of gravity. Okay, then I want you to take a look at the actual landing weight, and I want you to take a look at the actual landing center of gravity. Okay, or center arm. Right, so we finished with the first step. Now you have to check that the maximum weights are not exceeded, but we finished with the first step. If we did it correctly, and I really suggest you try again this thing and that you actually make sure you know how to do this calculation, we're gonna go to the second part. Okay, the second part, as you remember, is this one. Is locating the center of gravity into the limits, okay, to see if the flight is actually safe. So let's go to that graph and see how it works. First, we're going to take a look at the actual takeoff weight and at the actual landing weight. Okay, as I said before, we need the weights, we need the CGs. The same happens with the landing. We need the weight and we need the CG. And we are going to locate them in the graph. We're going to locate the CG or the arm here, and we're going to locate the weight up here. Let's see what we get. This first line in yellow right there is basically our takeoff calculations. Our takeoff calculations give us a point right there, okay, of 2,244.5 kilograms, okay, converging with another line that comes from the 41.22 right from here, okay, and it's going to create a point right there. That is our takeoff point. It means our CG is inside of the limits, okay. If this point is inside of the boundaries, it means that our takeoff is safe, okay. If it's inside of these boundaries, our takeoff is safe. All right, so it doesn't always depend on the weight, right? For example, for this weight, if the center of gravity was on 41.22 and instead it was, let's say, 35, we would be out of the limits, guys. So be careful. Both calculations are really important. Now, the next part is to do the same as you can see in the screen in red. Okay, we got the point for landing. We used 2,124.5 pounds against 40.84 inches of CG, and we got that point. All right, that landing point. That landing point is also inside of the envelope. Okay, We get it right there. So it is inside of the envelope. That means we are safe to fly. If the takeoff point and the landing point are inside of the envelope, that means our weight and balance is correct and we are fit to fly. Okay? So, after having finished this lesson, you've successfully completed the planning section of this course. Now it's an activity to keep your abilities and knowledge sharp. I encourage you to take the test for this section. Don't be scared. Don't worry. Remember, the test is there to help you. And after, I also want you to practice reading some NOTAMS, looking for the meteorological products we have learned about in this section, and maybe try to file a fictitious flight plan with a fictitious mass and balance calculations. Go to your training office if you are already enrolled in one flight school. Ask for all this documentation. Ask for help in the forum or at your flight school if you need to, because practice makes perfect. I think I already said it 100 times in the lesson. You're gonna be hating me, but I don't care. Practice makes perfect. Okay. So yeah, you have all these things in the documentation section. I really encourage you to go there and download them so you can practice as much as you want. Stay tuned. In the next lesson, we're gonna learn about the insides of the plane, okay? The systems. For now, keep practicing, keep studying. See you soon.